The objective of this exercise is creating a dataset in order to develop a machine learning core application. We will use a SensorTile.box Pro evaluation board, and we will program the machine learning core in order to behave like a joystick controller, classifying the hand movements. To do that, we'll go through first creating a dataset in order to collect four classes of data: none, forward, left, and right. We'll collect and tag the data while the data stream from the connected board is ongoing. And then we'll finally review and upload the just collected data. As I mentioned earlier, to create the dataset, we'll collect data directly from the sensor board connected to our PC. We'll hold the board in our hand. Before starting the online data logging phase, let's hold the board in this way. The ST logo clearly visible, the LEDs under our fingers, and the Type-C cable pointing upwards. The positioning ensures consistent alignment of the sensor axis. During the data logging phase, we'll tag and collect the data in this way. For the none class, we'll collect 15 seconds of data while making small random hand movements. For the forward class, we'll perform 10 forward movements with our hand. Let's move slowly enough the board so that the upwards and downwards peaks of the signal are clearly visible. For the left class, follow the same approach and perform 10 movements. For the last class, right, let's move the board 12 times instead. It is just a trick to have a dataset a little bit unbalanced. To create a dataset, you need to be logged in your account. So indeed, if I click here, as you can see, I already logged in my account. So I can now browse my workspace and entering the My Dataset sections. As you can see, I already created a dataset, but for the time being, let's create a brand new dataset from scratch. Let's click on Create New Dataset button. Let's enter some general information. So let's call it joystick dataset. The description field is optional. So now let's enter the classes that we saw before. None, forward, left, and right. Fine, let's create it. And as you can see, a brand new dataset has been created. Empty dataset, by the way. So now let's collect the data with the board. Let's click on the Log Data from Board button, top right. Let's connect the board to the PC, but I already connected it since we did together the previous exercise where we validated the Smart Asset Tracking project with the board connected to the PC. So the web application already recognized it as a connected. So let's establish the real connection with the device. And now everything is set up to start the data logging phase. Let's configure the sensors that we want to use for this application. So for this application, we'll use both sensors, built-in sensor in the machine learning core. So the accelerometer and the gyroscope. Let's configure them. So for the accelerometer, let's use a 4G as a full scale since we are just doing some hand movements. And as a ODR, let's set 240 Hertz. Let's move on the gyroscope, and for the full scale, let's set 500 as a degree per second full scale, and as an ODR, the same that we used for the accelerometer, 240 Hertz. Fine, we configured and enabled our sensors. Let's start with the data logging phase. So let's click on the Start button. And now let's browse a location where the data will be stored. Let's create a new folder. Let's call it joystick dataset. And let's select it. So now let's start with the data logging phase. We need to grant all the permissions in order to grant the web application access the file system, the local file system. Okay, so let's start. So let's start tagging the data. The data now are streamed by the board and stored locally in the PC. So let's enable the non tag, and let's do some small movements, random movements. So 15 seconds, as we said. Okay, let's disable, and let's start now collecting the forward class. So let's enable and let's do the movements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the same for the left class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So now let's start with the right one, the last class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. Fine, we collected 12 time classes, movements, sorry. So let's stop now. This is the recap of the acquisition. As you can see, it is quite balanced. Let's confirm now and upload the data that we stored locally on the cloud. So the data are stored in a, let's say, binary format in order to save space locally. So once you uploaded the binary data that you collected, the data will be converted on the cloud side in order to get a set of CSV files, one for the class that we collected. So let's wait some seconds before having those CSV files. Good. The conversion get succeeded. So if we refresh the dataset in this way and we access the data logs section, as you can see here, we have a set of files, one for each class. One CSV file for the non-class, another one for the forward, yet another for the left, and the last one for the right. Fine, good. The dataset has been created.